All right, this is the AP Calculus section 3.1 homework solutions. We're going to work through all of these on page 160. It'll be, this video is probably going to be pretty long because that's a lot of problems to go through. But hopefully you won't have to watch the whole thing. Okay, so number one, we just want to evaluate the derivative at the indicated point, which is 0, 0. So we're just going to take the derivative and plug in 0. So f prime of x going to be the bottom x squared plus 4 times the derivative of the top 2x minus the top x squared times the derivative of the bottom 2x over x squared plus 4 all squared. So if we plug in 0, f prime of 0, just plugging in the x value, well, this is going to make the whole thing 0, and then 0 squared is 0 times 0. So the top's going to be 0, the bottom will be 4, so that's 0 over 4, which is 0. All right, number 5, we have f of x is equal to x plus 2 to the 2/3. And we are interested in the point -2, 0. So we're going to take the derivative and try to plug in -2. F prime of x would be 2/3 times x plus 2 to the minus 1/3. I'm going to rewrite that as 2 over 3 times x plus 2 to the 1/3 power. All right, plugging in -2 there. So if we put in a -2, I would have 2 over 0, so it is undefined at the point -2, 0. Okay, next one, let's see if we can fit number 7 on here. So we're finding the critical numbers, and we have f of x is equal to x squared times x minus 3. So I'm going to rewrite that as x cubed minus 3x squared. So I have just distributed the x squared. So f prime of x then would be 3x squared minus 6x. We're going to set that equal to 0. Let's factor out a 3x. What you have is x minus 2. It's left. Let's make sure 3x squared minus 6x, so that's right, equal to 0. So our critical points occur when x is 0 and when x is 2. That would make this whole thing 0. All right, you have a lot of that in your future, determining critical points. Okay, we're off to a good start. Number 11. Okay, we have h of x is equal to sine squared x plus cosine x. And we're interested in the interval from 0 to 2 pi. So we don't have to keep going round and round the unit circle, just one time. All right, let's rewrite this as sine x all squared plus cosine x. Okay, that's the same thing. And then h prime of x would be 2 sine x to the first times the derivative of sine x, which is cosine x. And then the derivative of cosine is minus sine x. I'm going to set that equal to 0. That's a little bit of a pain. Let's factor out a sine x, and you have 2 cosine x minus 1 equals 0. So we need to determine where does sine x equal 0 and where does 2 cosine x minus 1 equal to 0. Well, sine x is equal to 0 at, if you look at the unit circle, at 0 and then again at pi and also at 2 pi. For this side of the equation, where does that equal 0? Well, let's say 2 cosine x equals 1. So where does cosine x equal 1/2? All right, looking at the unit circle, where does cosine x equal 1/2? Remember, cosine is the first, so it's equal to 1/2 at pi over 3, nothing in quadrant 2, nothing in quadrant 3, and it's also 1/2 at 5 pi over 3. So at x equals pi over 3 and 5 pi over 3. So our critical numbers are at those 5 points. So this is a good problem. It shows you, you got to do algebra with these trig functions sometimes. And find your handy-dandy unit circle. Okay, that's one. I recognize that one. I work that one probably every year, so I wouldn't be surprised if you're watching that one. Number 13. Okay, 13, we're just finding the absolute extreme. We're going to use that procedure where we look at the left endpoint, the right endpoint, and the critical point and find the max and min. So we have f of x is equal to 2 times 3 minus x. Our interval is from -1 to 2. Okay, first let's find our critical point. I'm going to rewrite this as 6 minus 2x. So f prime of x is going to be -2. Well, that does not equal 0, does it? It doesn't have an x in it, so there's no critical point. So I just have to look at the endpoints. Well, the left endpoint, we would have f of -1. So I'm just going to plug -1 in right there. So that would be 6 minus 2 times -1. 6 minus -2, that would be 8. And our right endpoint would be f of 2. And that's going to be 6 minus 4, which is 2. So we have a max. Our largest y value occurs at -1, 8. Right? -1 is the x value, 8 is the y value, and then we have a min that occurs at 2, 2. Okay. All right, 15, we've got f of x is -x squared plus 3x, and we are on the interval 0 to 3. Right, f prime of x would be -2x plus 3. We're going to set that equal to 0. -2x is equal to -3. So x is equal to 3/2, and that is our critical point, and that is within the interval. All right, so our left endpoint, we have f of 0. Plug 0 into the original equation, and you will get 0. Our critical point, we have f of 3/2. We're going to plug 3/2 in. That would be -9/4 plus 9/2. All right, and that'd be 18 over 4, so that's positive 9/4. And then our right endpoint, we have f of 3. So that would be negative 9 plus 9, which is 0. So we have our minimum y values are 0, and we have them in two different places. So we have a min at 0, 0. We have a max at 3/2, 9/4. And we have another min at the point 3, 0. Okay. Let's see. How long is number 17? Can I fit it in here? I'm going to say no on that. Okay, 17. We've got f of x is equal to x cubed minus 3x squared. And we are on the interval -1, 3. Okay, so let's first of all get a critical point. So f prime of x would be 3x squared minus 6x. Set that equal to 0. Let's factor out a 3. And you'd have x squared minus, let's factor out a 3x. That would be better. So it'd be x squared minus 2 equal to 0. So our critical points occur at 0 and 2. So I've got two critical points to test because they're both in the interval. All right, we always like to start with the left endpoint. We'll do f of -1. All right, f of -1 is going to be -1 cubed, -1 minus 3. -1 minus 3 would be -4. Okay, we have our first critical point. That's f of 0 equals 0. I like that. Our second critical point is f of 2. So it would be 2 cubed, which is 8, minus 3 times 4. 8 minus 12, -4. And then our right endpoint, we have f of 3. So 3 cubed is 27, minus 3 times 9, 27 is 0. So we've got minimums at the left endpoint and this critical point at 2. So this is a minimum, and it occurs at the point -1, -4. You actually have a maximum at 0, 0. We have another minimum because it's a tie at 2, -4. And another max at 3, 0. All right. Okay, number 22. I'm just going to go ahead. I think I could squeeze it in there, but why squeeze when you can erase? Number 22. So we have g of t is equal to t squared over t squared plus 3. And we are from -1 to 1. Okay, we're going to take the derivative. We've got to get a critical point. It's the bottom, t squared plus 3 times the derivative of the top, 2t, minus the top, t squared times the derivative of the bottom, 2t, all over t squared plus 3 squared. Okay, so the bottom will never be 0. So it's only where the top is 0. Okay, because it's squared, no matter what you put in, you add 3 and you square it, the bottom's never going to be 0. The top is going to be 0 at 0. When you plug a 0 in for this t and this t, you have a 0 there. So we have a critical point at x equals 0. So we only really care about the numerator. Where's the numerator equal to 0? And like you might think, okay, -3 or negative root 3, but that doesn't work because you square it, it makes it positive, so it's only at 0. So I've got to look at the left endpoint, and that is f of -1. So I have -1 squared is 1 over, so it's 1/4. Our critical point, so it's good to make a list like this. F of 0, that's going to be 0 over 3, which is 0. Right endpoint would be f of 1, which would be 1/4 again. So our max is not very tall. It's at, we have one at -1 1/4 because 1/4 is bigger than 0. We have a min at 0 0. And we have another max because it tied with the left endpoint at 1 1/4. And it's so easy to see what the x value is. It's the f of. So this is the x value. This is the y value. But it's the y value that tells you whether it's a max or a min. All right, 23. So I said this homework was short. That was a lie. It's just not that hard. Okay, 23. We have h of s is equal to 1 over s minus 2. And our closed interval is 0 to 1. All right, I'm going to rewrite this as s minus 2 to the minus 1 power. So h prime of s would be minus s minus 2 to the minus 2 times the derivative of the block, which is 1. So that's going to be minus 1 over s minus 2 all squared. Now, we do have a critical point at s equals 2 because that makes the denominator 0, but that is outside the interval. So we don't have to evaluate it. 2 is outside the interval. So we just evaluate the left endpoint. So that's going to be h of 0. And that's -1/2, right? Put a 0 in. -1/2. The right endpoint will be h of 1. And that'd be 1 over -1, which is -1. So we have a max. -1/2 is tall, is -1/2 is bigger than -1 by a little bit, by a half. So that's where we have a max at the point 0, -1/2. And we have a min at the point 1, -1. All right. 25. So what do we got here? We got another trig. Got students in the past that whenever they see the trig, they just hate it. Hopefully that's not you. F of x is equal to cosine pi x, and we are in the interval 0, 1, 6. So a tiny little interval there. let's see if we have a critical point in that interval. So the derivative, so we can think of it like this. So we'd have negative sine pi x times the derivative of the block pi x, so times pi. So that's minus sine, minus pi sine pi x equals 0. And in that little interval between 0 and 1/6, the only place sine is 0 is at 0. So sine of 0, when x is 0, then this whole thing would be 0. So we do have a critical point at x equals 0. Because pi is outside the interval. That's the next place. Okay, so our left endpoint is going to be f of 0. Now we're plugging it into the original equation, not the derivative. So that's cosine of 0, which is 1. Our critical point is f of, critical point is 0, so it's the same. So 1. So that's going to be the same. So we really didn't have to plug that in. Our right endpoint is f of 1/6. That's the cosine of pi over 6. So the cosine of pi over 6 is square root of 3 over 2, right? Okay, so the square root of 3 over 2, I believe, is less than 1, isn't it? Let's see. Square root of 3 divided by 2 is 0.866. So that's actually going to be a min. So we have a min that occurs at 1/6 root 3 over 2. And then we have a max at 0.1. Okay, so 1 is a little taller than the square root of 3 over 2. Okay, now we're going to move a little faster because we have graphs to read. Okay, 29 asks all of these graphs, so we have an A and a B. Asks, does it have a minimum or not? Okay, let's look at 29. It has a closed circle here. That means you can count it as part of the interval. And it is at the lowest point. So we do have a minimum on 29A. (29B), the minimum occurs at an open circle, which is not included in the interval. Okay, so we can't count that. So there is no minimum. So the answer is no there. There's also no maximum on that one because the tallest point is at an open circle. All right, 30. So it's just asking about a minimum. The minimum is at an open circle, so we can't count it. So that's going to be a no. The maximum also, on part B, the minimum occurs at a closed circle, which is indeed a part of the interval. So the answer is yes. Okay. And then 31. The minimum is right down here. That's the lowest point on the graph, and it's at an open circle, so the answer is no. So that point there doesn't help. Now, if the point was down below, then we could count it, yes, but it's not the case here. So the answer on 31A is no. (31B), though, well, is what I gave the game away, didn't I? 31B, we have a closed circle beneath the lowest point on the graph. So that is in fact the lowest point, and it's a closed circle. So yes, on that particular depiction, the answer is yes. Okay, so we are now at number 33. All right, and we have for part A, the interval is 0 and 2, and we want to know, it's closed interval, what is the max and what is the min. In a closed interval, you will have a max and a min between 0 and 2. So the maximum occurs at the point 2, 1. That's the highest value on that graph. The minimum occurs at the point 0, -3. Right down here, 0, -3. Again, this is a closed interval, so it's continuous, so it's going to have a max and a min. Part B, the interval is closed on the 0, but open on the right endpoint. Okay, so it's an open interval up here. That means there would be an open circle there, so we can't count it. We don't have a max. We do have a min, though, and that is because we have a bracket around the 0. That's at the point 0, -3. All right, see, it's 0, and the 2 is enclosed by a bracket. So this is going to be the reverse. We have a max because we get to count the 2 at 2, 1. But we don't have a minimum, because the minimum occurs at when x is 0, and that we don't get to count because it's up against a parenthesis, not a bracket. And then part D, both endpoints are open, and there's not a point in between, like way up here or way down here. So that means we have no max or min. Okay. It's 35. Similar kind of thing. We have a graph here, and part A, our interval is -1 to 2. All right, so between -1, that's the x value, -1 right here, and 2. We want to get the extrema. Well, the maximum occurs at -1, and if I follow that up, the tallest y value is 3. So the maximum occurs, now I'm just reading the graph, at -1, 3. The tallest y value occurs at -1. All right, the minimum happens not at the endpoint 2, but at 1. So it's at 1, -1. This part, it's continuous, and the lowest point on this function is at 1, -1. Okay, we have 1, 3. Okay, so let's see, between 1 and 3. So 1 we can't count because it's up against an open parenthesis. All right, so in this particular case, our lowest point is at 1, and that is an open interval there at 1. So there's no minimum, but the max does occur at 3, and that would be at 3, 3. Best I can read this graph at when x is 3, y is 3. But there's not a minimum. All right, we have 0 to 2. Both are open. So the maximum between 0 and 2 is at y equals 0, but those 2 points are open. So there's not a max. There is a min, though, in between them, because that's not at an endpoint at 1, negative 1. So the max is none, but we do have a min at the point 1, negative 1. In part D, it is 1 and 4. All right, so our maximum on the graph would occur at 4, but that's an open interval. All right, so there's no max there, all right, because the graph is going up, but when you get to x equals 4, it's against the open interval, so the max would be none. But we do have a minimum, and that occurs at the point 1, negative 1, all right, because we get to count the value at 1 because it's up against a bracket. Okay, number 48. Go ahead and erase. There's a lot of explaining on this video. This video will take a while to upload. All right, 48. We're on page 162. So we have a cost function. C is equal to 2x plus, I'm going to go ahead and change that to 300,000 x to the minus 1. It's 300,000 over x. And our interval is between 1 and 300. And we include the endpoints because it's less than or equal, less than or equal. That equal part means you include the endpoints. If you remember that from Algebra 2. And maybe also some in pre-cal. So we need to see where the critical point is and see if it's in this interval because we have to evaluate. So ultimately, this number 48 is just like the ones that you did between number 13 and number 25. You do it the same way. So C prime would be 2 minus 300,000 x to the minus 2. So that's 2 minus 300,000 over x squared. We're going to set that equal to 0. So let's move this over to the right, and I would have 2 is equal to 300,000 over x squared. Let's multiply both sides by x squared. So 2x squared is equal to 300,000. Divide both sides by 2. X squared is equal to 150,000. So take the square root of 150,000 and just rounding, that's 387. That's our critical point, which is outside the interval. So I don't have to look at it. So it's not between 1 and 300. So let's look at the left endpoint. That is f of 1. That's going to be 2 plus 300,000 over 1. All right, so that is 302,000. Now we're looking for a minimum. So hopefully that's not the minimum cost. Our right endpoint, and that actually would be C of 1. Sorry about that. C of 300. That's going to be 2. That's going to be 600. 2 times 300, 600 plus 300,000 over 300. and that is $1,600. And that is much less than $302,000, so we know that is our minimum cost. All right, and this is the order size, right? So we want an order size of 300. Which is the maximum the truck can bring. So that's what you want to bring. Now part 2 of this is, all right, so I'm going to go ahead and erase this. We're going to use a lot of the same stuff, but the interval is between, it says the truck could bring 400. So in that particular case, the critical point is 387, so we have to look at that because that's in the interval. So the left endpoint doesn't change. C of 1 is 302,000. Our critical point is C of 387. So if we plug 387, 2 times 387 plus 300,000 over 387, we get 1549.20. And our right endpoint, we have to plug in 400. So if we plug 400 into the original equation, you get 1,550. So it's slightly cheaper to order 387 than it is 400. Not enough to matter, 80 cents. I'd probably just order the 400. So for this time, the minimum occurs at an order size of 387, and it would be that. All right, excuse me. Okay, this super long video is almost done. 53. True and false, it says the maximum of a function that is continuous on a closed interval can occur at 2 different values in the interval. Well, that's true. You can have a max occur. We even did that in our homework. We had some ties, right? So you can have a max occur twice, 3 times, infinite number of times. 54. If a function is continuous on a closed interval, then it must have a minimum on the interval. If it's continuous and the interval is closed, that's absolutely true. It has to have a minimum and a maximum. But that only occurs if it's continuous and closed. Then it must have a minimum and a maximum. That is the extreme value theorem. All right, that does it for this video. My goodness, maybe the longest one I've ever done on homeworks. But hopefully you didn't have to watch the whole thing, but I hope it helped, and I'll talk to you next video.